Good morning, everyone. Good morning to this lecture. This is
Morning,
lecture
sir.
number 9. Yes, beta? Any doubts? Okay. We are dealing with acceleration. In the last class, we had seen problems where we had position of the particle given to you and you were supposed to find out the velocity and the acceleration. Do we remember this? Yes or no? Okay. We have, even though the name of the chapter was motion in 1D, but as you can see, we had actually solved questions of many Ds. Yes or no? We had also solved questions on motion in 1D specifically. And this was the question that was there, right? I'll just to remind you of what we had done, I'll give you one more question. And this question comes from your sheet. Or maybe I'll give it from your module. Do you have your module with you? Do we have your module with you, Vita? Do you have your module with you, Bacha? The module that has questions, that has the study material. You have that study material module with you? Yes or no? Okay. So this is a question from the module itself. And I hope that you can give me the answer for this one. Why the different color? Answer for this one. Question number 1. The position of a particle as a function of time is given by x is equal to 5t square plus 4t plus 3. First of all, tell me, what type of motion is this? Is this motion in 1 dimension, 2 dimension, or 3 dimension? I hope I am audible and visible to all of you. Yes or no? You can all hear me. You can all see me, right?
1 dimension.
Yes, this is motion in 1 dimension. It is not mentioned because only x coordinate is given. Do you see this? Only x
Yes, sir.
coordinate is given, right? So this has to be motion in 1 dimension. Specifically, this will be motion along x-axis. I wait for your answers. What are to find out the velocity and acceleration of the particle as a function of time? Let's see who gives me the answer first of all.
10t plus 4.
Okay.
And when we equate t is equal to 2, then we get 24.
Correct. What about the acceleration, bacha? Velocity is 24. What about acceleration?
12.
Okay. Everyone got the same answer? Or do we have different answers from different students? Okay, let us go about it. The position of the particle is given, so I have to find out velocity. Velocity is dr by dt. All of us know it. We differentiate this equation with respect to time. 5t square, 5 comes out. T square derivative is 2t, so this gives us 10t. We all understand this, yes or no? 10t. Then we differentiate 4t. 4 comes out. Derivative of t is 1. So 4t plus 1. Then we differentiate 4t. The derivative is 4. Then we differentiate 3. The derivative of 3 is 0 because it is a constant. So my velocity is what I get, 4t plus 4. Yes or no? You got this? 4t plus 4. Now the first question that I'm going to ask, and I will keep on asking this, is this uniform velocity or is this variable velocity? Is this velocity constant or is this velocity variable?
Non-uniform, sir.
Non-uniform. Variable. Why? Please tell me the reason. This is a variable velocity, non-uniform or not constant velocity. Why is that so?
Time varies, sir.
Yes, well done. So now you are understanding the concept. It depends on time. So it changes with time. If something changes with time, it cannot be a constant. Let us move on and find out the acceleration. Acceleration, as you all know, is the derivative of velocity dv by dt. I differentiate it once more. What is the answer? Derivative of 10t, 10 goes out. Derivative of t is 1, so this is simply 10. Derivative of 4 is 0 because it is a constant. So my acceleration that I get is 10. I again ask you the same question. Is this constant or is this variable?
Constant, sir.
This is the example of a constant acceleration. That means this question is an example of uniform or constant acceleration. Do we understand this?
Yes, sir.
Now the question is, we had to find out velocity and acceleration at 2 seconds. To find out the velocity at 2 seconds, what do? I write it as v2. So basically, I will put the value of time as 2 seconds. Do we understand this? I will put the value of time as 2 seconds and get the answer. So if I put the value of time as 2 seconds, 2 into 10 is 20. My answer would be 24 meter per second, assuming that everything is in SI units. But about acceleration, what is the acceleration at 2 seconds? There is no way I can put time here because acceleration is constant. Therefore, the answer is simply 10. Whether you ask acceleration at 2 seconds or 3 seconds or 4 seconds or 5 seconds, the answer remains same. Do we understand this? That means when the acceleration is constant, when the acceleration is constant, whatever you say will remain same about acceleration, and we will see it in the equations that we are going to do just now. Do you have any idea about integration? This is a yes, this is a no. No? Okay. So I'll take a special class on that, and after that class, we will do problems where instead of differentiation, we'll have to do integration. Okay? Right now we move ahead. What is the next heading that we are supposed to write? What is the next heading? Next heading comes from this question that we have done just now. Motion with uniform acceleration. Do we understand this? So we write equations of motion. Equations of motion. We start with the equations of motion. Now, in these equations of motion, we would be using certain terms. I am sure you know about those terms. Okay, now this equation of motion that we are going to write are basically meant only for one particular type of motion, and that particular type of motion is with uniform acceleration. That motion is with uniform acceleration. Do we understand the meaning of uniform acceleration? Anyone understand the meaning of uniform acceleration? Acceleration is constant. Do we understand this? Acceleration is constant, acceleration remains same. So I can say, if someone tells me average acceleration between any 2 points, that will be equal to instantaneous acceleration. Acceleration at all the points is going to be same. So whether you find out average or you find out instantaneous, everything will be equal. Yes or no? Then there is a small thing that we can understand, and we will understand it while we write the equation. Now, we will write two types of equation. One type of equation are vector equations, which are valid whether the motion is in 1D, 2D, or 3D. Then we will write the equation not using vectors, but when we are not using vectors, the equation will be written for one axis only. Whether you can write it for x-axis, or you can write it for y-axis, or you can write it for z-axis. Do we understand this? If we write the vector equation, one equation, all the dimension, it is valid. But if you write the same equation not in the vector form, we cannot write it for all the three axes together. For each and every axis, we have to write it separately. We understand this? Let us go about and write the first equation of motion, which is again, remember, valid only for uniform acceleration. And the first equation that we write is v vector is equal to u vector plus a vector times t. I hope you understand the meaning of terms here. What is v vector?
Final velocity, sir.
Final velocity. What is u vector?
Velocity.
Initial velocity. What is t?
Time.
T is time. What about a? What is this a?
Acceleration.
Okay. This a is acceleration. Which acceleration? Instantaneous acceleration or average acceleration?
Constant. Instant,
Acceleration,
sir. Instant.
acceleration is constant, so you can call it as average acceleration, or you can also call it as instantaneous acceleration. Do you know how this equation is derived? This equation that I've written, if you remember the equation for average acceleration, do you remember what was average acceleration? Final velocity minus initial velocity divided by time. Do we remember this? Yes or no? Now, if the acceleration is constant, my dear friends, this average acceleration can also be written as instantaneous acceleration. If I cross multiply and take u on the other side, this equation will give me this equation. Do we understand this? So basically here, acceleration is constant, therefore you can write this equation. We understand this, yes or no? Okay, then we go about writing the second equation. Remember, the second equation will be the equation of displacement. In your books, you will find it as S, but I will not write it as S because S I'm using for speed. So I will write it as delta R. Delta R vector is a vector equation. I hope you know this equation, ut plus half at square. Yes or no, my dear friends? Again, here A is the instantaneous acceleration, average acceleration, whatever you call it. It remains same because acceleration is constant. We understand this? Now this displacement can be written as R2 final position minus R1 the initial position. Do we understand this? So you can write it like this also. That is my third equation that I am concerned with. I hope everyone is writing the equation together with me. Yes or no? Okay. Now, the third equation, can anyone tell me the third equation? Third equation, which you might have seen and which I am going to write in the vector form, they might look a bit different, but I can't help it. I have to write. It looks like this, v dot v. This is a dot product. Have you heard about dot product of vectors? Well done. Then you must understand is v dot v is u dot u plus 2 times a dot displacement. This is how the third equation looks like. This is how the third equation looks like when you write it in the vector form. Do we understand this, my dear friends? Okay. The fourth equation, which I am going to tell you, is this one. Displacement in the nth second, third second, fourth second, fifth second. Displacement in the nth second is u plus a by 2 into 2n minus 1. These are the four equations. I might tell you more equations depending on where we reach, but these are the four equations. Remember, out of these four equations, to solve any question that ever comes, you only need two. You only need to solve any two. But the reason you have to remember or understand all the four equations is simple, that in some cases, some questions can be done very quickly by equation number 1. In some cases, question can be done very quickly by equation number 2. In some cases, they can be done very quickly by equation number 3. How will you understand which equation you have to use? Well, that will come by practice. The more the questions you practice, the better you will understand which equation should I apply here. Do you understand this? For example, if in a question they ask you the final velocity, they give you the initial velocity and then you give you the displacement and acceleration, then you must use equation number 3. But if they give you initial velocity, acceleration and time, then you use equation number 1. So basically, depending on what is given to you and what is asked from you, you choose your equations wisely. Doesn't matter which equation you choose, you will always land up with the correct answer. The only thing is, if you don't choose the very correct, all the equations are correct. If you don't choose the shortest equation, it will take some time for you to get the answer. And remember, JEE Mains is a test of your speed. You have to get answers quickly. And that is why it is necessary that you practice as many questions as possible so that you understand in which question you have to apply which equation. We understand this, everyone? Coming on the right hand side, I will write the same equation but not using vectors. But again, if I write the same equation not using vectors, I cannot write a general equation. I can only write equation along one axis. So if it is equation in one motion, equation in one dimension, one equation, one axis will do. But if it is equation motion in two dimension, I will have to write two separate equation, one along x-axis and one along y-axis. If it is motion in three dimension, then I will have to write three sets of equation, one along x, one along y, and one along z-axis. Do we understand this? That is the small thing that you have to understand. So now on the right hand side, we will write the same equation without using the vector sign. But without using the vector sign, there is one more problem. Vectors have direction. Now, if you are not using vector sign, how will you understand the direction of these vectors? Anyone can tell me? I have told you one problem. One problem is I have to write them separately, x, y, and z. The other problem is, how will I understand the direction? What can I do to understand what is the direction? Okay, I understand that equation is along x-axis, but in x-axis also I have two directions. I have one direction like this, and I have one direction like this. How will I understand which direction the vector is, this or this? So I have to use something. What will I use?
Negative positive signs.
We will use positive or negative signs, and that is why you might have heard positive velocity, positive acceleration, negative acceleration. They all refer to the direction. And how do I assume their direction? Remember, these are just my assumptions. So what do I do is I make one convention, and I will always keep that convention with me, and I will not change it no matter what happens. So I'm going to tell you what convention I'm going to use. So this is, as you can see, this is your plus x-axis. This is your minus x-axis. If the motion is taking place along x-axis, the best way to give a sign is that if someone is going like this, if a vector is like this, I will call it positive vector or positive. Do you understand this? It is simple because it makes sense. Positive x-axis, let us call it positive. Then if anything is moving along negative x beta, then it automatically becomes negative. Do we understand this? So if the motion is taking place along x-axis, this will be my convention. This is positive and this is negative. Now I have sorted my problem. I have also assumed plus and minus for direction. Remember, plus and minus are only for direction. They do not tell us how big or how small that is. For example, if I say one velocity is plus 5, one velocity is minus 7, which velocity is more, plus 5 or minus 7? One velocity of one object is plus 5, the other is minus 7. Which is more?
-7.
Why minus 7? This is not maths. This minus sign only indicates the direction. The magnitude of that velocity is 5 and the other velocity is 7. 7 is more than 5. Minus does not mean that it is less. Minus only means that it is going in this direction. Do we understand this? And this will be valid throughout physics. Minus 5, 7 is not less than plus 5 because minus may refer to the direction. We understand this? Similarly, if a body is moving along y-axis, so if it goes up, I will take it as positive. If it goes down, I will take it as negative. And I will not change this sign convention whatever happens. Because I don't want to use, in one case, in one question I take one thing as positive, in the second question I take the same case as negative. That happens in most of the cases. Students have doubt, sir, whether the value of G, you know G? Do you know G? G? This G? This G is acceleration due to gravity. In most cases, students get confused, sir, what should I take G? Should I take G as positive or should I take G as negative? Sir, I have seen in some books, when the body is going up, G is taken as negative. When the body is coming down, G is taken as positive. Sir, I get confused. What should I do? I ask you this question. G, acceleration due to gravity, is assumed to be constant and it is always going downwards. What will you take G as? Whether you will take it as positive or whether you will take it as negative, or you will say, sir, it depends. Sometimes I will take it positive, sometimes I will take it negative. Yes. What do you think? You should be taking G as?
Depends.
No, it does not depend. In our case, it does not depend, beta. Because in our case, what we have assumed? In our case, what we have assumed? That anything which goes downwards will be taken as, any vector which is downward will be taken as
Negative.
So for our case, and in the way that you are going to solve any question, G is always negative. G does not change its sign depending on the motion of the body, because G is always downwards. Do we understand? And I am not going to change my sign convention for one question. This is my sign convention. It will always remain my sign convention, no matter what happens. Do we understand this, bacha? So G, whenever G comes, it is going to come in the next class probably. G will always be negative. So don't look at the solutions in the book. They might take G as positive sometimes. They might take G as negative sometimes. Doesn't matter. The book is not going to solve questions for us. It is us who are going to solve questions for ourselves. Yes or no, bacha? Let us now move on. So we have now eradicated all the problems. X-axis, Y-axis, Z-axis. I have to make separate equations, and then I'll have to take conventions. Z-axis normally question doesn't come, so I have not told you the convention along Z-axis. If required, I will tell you. Let us now write the first equation. Now I will not use a vector sign. I will just use plus and minus whenever I put the value. So what is the first equation now? It is same as the equation on the left hand side, but without the vector sign. So I will write it as V is equal to U plus AT. Do we understand this? This is the form in which we have seen this equation, and now we have come to that form. Second equation is the displacement equation. Delta R is equal to UT plus half AT square. Third equation, now it looks better. V square is equal to U square plus 2 times A multiplied by delta R. Fourth equation is the displacement in the nth second. I will do questions on that, don't worry. Displacement in the nth second, and that is U plus A by 2 into 2n minus 1. These are the four equations, and remember, you don't have to use all of them. You can do it just by using any two also. So I'll give you 2 minutes to write this. Once you are written, please let me know. Yes, bacha. Have you written? Have you written the equation, bacha? Shall I move ahead in life? Okay, we can do a special case also. And what do I mean when I say special case? What happens if acceleration is 0? If acceleration is 0, and you can put the value of A as 0, the equations become very simple. Yes or no? The first equation becomes V is equal to U. That means velocity remains same. There is no acceleration, velocity has to remain same. Do we understand this? The second equation becomes displacement delta R is equal to U multiplied by T. Yes or no? So if acceleration is 0, the equations become very simple. If I write it without the vector, it will be V is equal to U, and it will be equal to delta R will be equal to U into T. But remember, whenever you are using these equations, you must remember that they must be used with proper sign conventions. Without the sign convention, if you are using these equations, you would be committing a mistake. Have you noted this down, beta? Shall we move on to some questions? Okay. Let me get some questions for you. Let us start with the simplest possible questions so that you get used to the equations. and then I can give you questions from your sheet and the questions from your module. Okay. A car moving with velocity 30 meter per second and acceleration 5 meter per second square find the velocity and displacement in 2 seconds. Find the velocity and displacement in 2 seconds. Simple equation. It is not given in which direction the car is moving. You can assume that it is moving along plus x. Acceleration is also in the same direction, so it also becomes plus. And you can tell me your answers so that we can move ahead with the next set of questions. I'll give you 2 minutes to solve this. It's good. I see everyone solving the question on their own. That is a good sign. Well done, bacha. See, answers are not important. Even if you get absolutely wrong answers, doesn't matter. As long as you try. And if you try, you are supposed to get, you will get the correct answer. And really very glad to see every one of you solving the question. Well done, bacha. Well done. Chalo, I'll give you time. Don't worry. Don't worry about the answer part. You may not get the correct answer in the first time. Don't worry. We'll be doing enough questions. And remember, even if you do one question in the entire class, every question before that you can solve, because I always give you question in that way. If you just solve one, that means all the above you can solve. Have you done this? Anyone got the answer? Okay, girls got the answer, I think. What about the boys? Okay, I think you need more time, or do you want me to solve it? Okay, now it is, let me do it. While you are doing it, I also do it. Remember, as I told you, it's always good to draw a diagram in every question. And in this question, it is not needed actually, but you will encounter a question where you need it. So you can draw a simple diagram just to begin the question and to understand the question, what is there. So basically what is happening here is, oops, this is not good. I will try to make it again. So what is happening is, I'm assuming that this car is moving in a straight line. It was at point A when its velocity v was 30 meter per second, and it has an acceleration which is 5 meter per second square, and it is not given anything, so I will assume that this acceleration is constant. We understand this. This is point B, and it has taken, let us say, 2 seconds to go from A to B. What I am supposed to find out is, at this point, what is the velocity at point B. I already know the acceleration because the acceleration is constant, and I have to find out the value of this displacement. Yes or no? These are the two things that I have to find out. I will start. The first thing that I'm supposed to find out is the value of velocity at point B. Now what I can say is, if I start from point A, my A becomes initial point. So this velocity becomes my initial velocity. Yes or no? and this becomes my acceleration. I have to find the final velocity. So which equation I am going to use? I am going to use v is equal to u plus at. Now remember, with proper signs I have to use it. So
So
u,
delta R is equal to 50 meters and initial velocity is equal to 20 meter per second.
okay, well done. 20 or 40. Okay, let me try it. U, initial velocity, is taken as plus 50 because I've assumed that this direction is positive. Everyone understands this? Plus acceleration is also in the same direction. It is not given as retardation. So I'll assume that this is acceleration. So this is also plus 5 multiplied by 2. I hope you can. Why written plus 30? It is plus 50. Why written plus? Oops. Something has gone. Okay. So this is plus 30 plus 10. So the final velocity will be plus 40 meter per second. Plus tells me that it is in the same direction. Do we understand this, bacha? Everyone? Then I can use the second equation, delta R is equal to ut plus half at square. It is very simple. I will just put the values. U is plus 30 multiplied by t, 2 plus half of acceleration is plus 5 into 2 square. I think you can tell me the answer of this. What is the answer, bacha? Plus 70, is that so? Yes or no? That is the answer. How many of you got this answer, bacha? Girls, boys, well done. Welcome to motion in one dimension. And this is how questions are done. Just take a deep breath and see what all quantities, information are given to you, what is asked. You only have three equations. The fourth one is displacement in the nth second. We will do questions on that as well. Forget about that. You only have three equations. Choose the wisest equation, get your answers, and stay happy. Can you do the next one? I'll give you 2 minutes to note this question down. Take your time, bacha. If you have any doubts, whatever is creeping in your mind, please feel free to ask me those doubts. Remember, no doubt is useless. All doubts are important because from those doubts, we'll understand a lot of things. Have you noted down the question, bacha? Have you noted down the answer in question? Yes or no? Can you move on to the next one? Read the question carefully, see what is given, see what is asked. Only three equations, choose the best one. Here comes the next question. The velocity of a bullet is reduced from 200 meter per second to 100 meter per second while traveling through a wooden block of thickness 10 centimeters. The retardation, assuming it to be uniform, when they say retardation, it is opposite to the direction of velocity. Do we understand this? Well done. The retardation, assuming that it is uniform, is how much? And I await your answers. I'll give you 2 minutes. Choose the best equation. That doesn't mean that if you choose the wrong equation, you will not get the answer. You will get the answer, but it will take some time. 2 minutes you have. Yes, my dear friends, do we have an answer? What all information is given to you? What is this 200 and what is this 100? This 200 is your initial velocity, yes or no? This 100 is your final velocity, yes or no? And this 10 centimeter, remember it's centimeter. This centimeter is your displacement. You are supposed to find out you are supposed to find out retardation. Which equation you should use? You know u, you know v, you know displacement. You have to find out the acceleration or retardation. Which equation you should use? Tell me. Equation number 1, 2, or 3. Which equation you should use? 1, 2, or 3?
3.
3. That will give you the answer in the fastest time, quickest. V square is equal to u square plus 2 times a into delta r. Your v square is plus. I'm always writing plus so that you understand that we are referring to the direction. Will be equal to plus 200 square plus 2 times acceleration multiplied by this 10 centimeters. So I have to convert it into meters, 0.1. Do we understand this? So from here, you will get the value of acceleration. It will be coming as negative. So you call it retardation. How much is it coming, my dear friends? A, B, C, D. I think it will be coming this one. Yes or no? Option D? Yes?
Yes, sir.
That is the correct answer. How many of you got this? Please raise your hands. Okay, don't worry if you have not got this answer in the first case. Note down this. I'll give you more questions. Don't worry. Similar question has come in your JEE many times. This one is taken from one of the previous papers. Has everyone noted it down, bacha? Shall I move on to the next question? And this is the next one. A car moving with a speed of 50 kilometer per hour. So this kilometer per hour and meter per hour, whatever, meter per second. It can be stopped by brakes after 6 meters. 50 kilometer per hour. It can be stopped in 6 meters. If the same car is moving with 100 kilometer per hour, what is the stopping distance? Same car, same acceleration. That is why it is said, move slowly. I give you 2 minutes to solve this. You can do this, yes or no?
Sir, answer D.
We have an answer. Answer is
D, sir.
D.
Yes, sir. D.
That is correct. How many of you got the answer? Answer is D. How many of you got this? Well done. Now, how are you supposed to do it? Remember, whenever you do a question, you try to understand the concept and you make a concept and you remember it so that if another question comes, you should be able to do it quicker. So, which equation I need to use here? The velocity, initial velocity is given, u, and the displacement is given, right? And again, in the second case, initial velocity is given and they are asking you the displacement. So velocity and displacement, they're only related in equation number 2 and equation number 3. But in equation number 2, velocity is there, time is there, and acceleration is there. All the four quantities are there. Therefore, the best equation to use here, which relates initial velocity, displacement, and the final velocity, because final velocity is 0. Yes or no? Initial velocity, final velocity, and displacement is given. So which equation you must use? The answer is very simple. You must use equation number 3. Yes or no? This is the equation that you use. V square is equal to u square plus a into 2 times u square plus 2 times a into delta r. What is the final velocity, my dear friend? First case, final velocity is 0. Yes or no? Initial velocity is plus 50 kilometer per hour. So we have to convert it into meter per second. That is one task. Let us keep it at kilometer per hour. Remember, it is in kilometer per hour. I have not converted it. Plus 2 times acceleration, I don't know, into the displacement. Displacement is given as 6 meters. If you want, you can convert it into kilometers. So now my acceleration or whatever will come in kilometer per hour square. This is, let us say, equation number 1. Now I'll make similar equation for the second case. V square is equal to u square plus 2 times a into delta r. In this case also, final velocity is 0, initial velocity is plus 100, plus acceleration, because it is the same car, will be same, multiplied by the displacement. I don't know, let me call this as x. Now you can easily solve equation number 1 and equation number 2. There are many ways you can solve equation number 1 and equation number 2. From equation number 1, you can find out the value of a and then put this value of a in equation number 2. That is one way. The second way is you can divide equation number 1 by equation number 2. A will get cancelled and you can get your answers. Do we understand this? Yes or no? Or
Yes, sir.
you could have just understood this one thing rather than doing this all. See, if I just start from here, v square is equal to u square plus 2 times a into delta r. When the car is stopping, final velocity is 0. 0 is equal to u square plus 2 times a into delta r. If the car is same, acceleration is same. That means your displacement in which it will stop will be directly proportional to u square. Are you getting my point? This is how you can make a concept and get your answers quickly. You are going to get the answer from here. Yes, we are doing the same thing. Not a problem. Here, first of all, you will think, sir, this is in kilometer per hour. First, I'll change it into meter per second. You might waste time there. Then you say, okay, instead of changing into meter per second, I will change distance into kilometer. You are wasting a lot of time. Are you getting my point, beta? You are wasting a lot of time. Are you getting my point? But here, if you look on the other hand side, right hand side, if you understood that this displacement is proportional to u square, displacement is proportional to u square, then you can write displacement in case number 2 will be equal to displacement in case number 1 multiplied by how much the velocity has changed. Displacement is proportional to u square, so this will be equal to u2 square or u2 by u1, u2 by u1 iska whole square. Do we understand how I've got this equation? Displacement is proportional to u square. When the velocity is 50 km per hour, it is taking 6 meters. I have doubled the velocity, 50 to 100. If I have doubled the velocity and displacement is proportional to square, the displacement becomes 4 times and you get the answer as 24. Do we understand this, bacha? I've done the same thing, but I've done it more smartly. If I do it this way, what I'm going to do is I'm going to save some time. So you do it by the first way or you do it by the second way. Both the ways are similar. In the second way, I've just taken the proportionality and used it. Do we understand this, yes or no? So everyone understood till now? We will be continuing with this class, with the same topic in the next class. Equations of motion with uniform acceleration. We'll then move on to motion under gravity and wind up this chapter with your graph. So I'll see you in the next class. Take care. And you have your sheets. Please solve questions from that sheet. The more the question that you solve, the better you will become. I'll see you in the next class. Take care and have a nice day. If you have
Thank
any
you, sir.
doubts, please ask me.
Thank you, sir.
Bye, beta.